Hello everyone, welcome back to our digital VLSI channel. I hope you guys are doing well. In this video, I'm going to discuss about implementation of half adder using NAND gates only. So as we know, the half adder is equal to A XOR B, which we already discussed in the previous videos. If you have any doubts, please go and check out. So A XOR B. So carry is equal to A into B. So we can write A XOR B is equal to A bar into B plus A into B bar. For simplification purpose, I'm adding A into A complement plus B into B complement. As we know, A into A complement is equal to 0, B into B complement is equal to 0. So this won't change even if I add these two. So I'm taking B as common from first and last terms. So A complement plus B complement, and here I'm taking A as common. So B complement plus A complement. As per Boolean theorems, A complement plus B complement, we can write it as AB bar A into AB bar. So here we need to convert our sum terms into product terms. So here I am considering double complement. So again A plus B whole bar. As per Boolean theorem, we can write it as AB bar. So B into AB bar whole bar into A into AB bar whole bar, and then one more complement. And this is the sum. For carry, we can write this is a carry. I'm using double complement here. Now let's draw the hardware circuit. First, this is A, B. So I'm connecting to one NAND gate, and this one. And this is AB bar from A and AB bar. I'm connecting to another NAND gate from B, AB bar. I'm connecting to another NAND gate from here, and this complement. One more NAND gate, and this is the sum. For carry, from here I'm giving complement of NAND gate, and this is the carry. Yeah, this is about half adder circuit using only NAND gates. Here we use total 5 NAND gates. I hope you guys understood. Thanks for watching, and don't forget to like, share and subscribe for more interesting videos. Thank you.